Today we're going to look at interquartile range, and our learning goals for this lesson are that by the end of the lesson you'll be able to find the 5-figure summary for a set of data, determine the interquartile range of a set of data, and also determine the upper and lower bounds on any outliers in a set of data using the interquartile range. So quartiles divide the data into 4 equal parts. So if we were to order all of the data from lowest to highest in ascending order, then our quartiles will split that data into 4 even portions. It will allow us to see how the data spreads itself out. So the 5-figure summary consists of the minimum and maximum value. So the minimum is the smallest value, all the way down in ascending order up to the maximum value, the largest value. The median is the dividing the data into 2 equal parts, a lower part and an upper part. And then we have our lower quartile Q1 and our upper quartile Q3. So we have our data then spread evenly out and split into 4 equal parts. So in order to determine Q1 and Q2, firstly, if we've got all of our data arranged in ascending order, so all of our data are arranged from lowest all the way to highest here, so our minimum value is down this end and our maximum value is down this end. We determine our median by finding the middle value, Q2 here, so our median exists right in the middle of the data, splitting it into a lower half and an upper half. So this is the lower half, and then there's the upper half up from Q2, from the median all the way up until the maximum value. If there's an odd number of scores, we remove the median, so we don't worry about the median and just worry about the values lower and the values higher. So to find Q1 then, we find the median of the lower half. So we look at just the lower half numbers and we find the median there. And then to find Q3, the upper quartile, we find the median of the upper half. If there is an even number, we don't remove the median, so we just leave, because the median will be the average of 2 values, there's no number to remove, so we just look at how it's split to the lower and upper halves of the data. The interquartile range is the range between the Q1 and Q3. So we can find the range by looking at the maximum value minus subtracting away the minimum value, but the interquartile range is the spread between Q1 to Q3. So that's the IQR, interquartile range. So let's look at an example now. We've got a data set here and we're asked to find the 5-figure summary. So that's the minimum and maximum values, and Q1, 2 and 3. That's the lower quartile, the median and the upper quartile. So, and then we're asked to find the IQR. So firstly what we need to do is we need to order our data from lowest to highest. So we've done that here, ordering the data from lowest to highest. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 values. So because we've got an odd number of values, we can find our median is going to be our just one middle value. We don't have to worry about splitting the middle value, and it's going to be, because we've got 13, it's going to be the 7th value as we go along. So 1, 2, 3, 4, 5, 6, 7. So our median here, our middle value is going to be 4. That's our Q2. And we're going to remove that value when considering the quartiles. Other ones that are going to be easy to find are going to be the minimum and maximum values. So we can start listing those now. So if we have a look here and we go our minimum, our Q1, Q2, Q3, and max, we can start listing our 5-figure summary. So our minimum is 1, that's our smallest value, our maximum is 18, and our median we found is 4. Okay, so now we need to find Q1 and Q3, so we're going to consider the lower half and the upper half. Firstly, we'll work with the lower half, so the lower half here, and because we've got our median there, we're not worrying about our median, we're discounting it. So we're looking at just what's up above the median and below the median. So if we have a look below the median, we've got our lower half here, and we've got 1, 2, 3, 4, 5, 6 values. So that means our Q value for Q1 is going to be the median of that lower half. So the median here is 2. Okay, the median of that lower half is 2, and so that means our value for Q1 is 2. That's our value for Q1. Q1 equals 2. If we have a look at our upper half now, looking at the upper half here, the upper half, because we've split it evenly, we've got 6 values here as well. So our median here is going to be the average, the mean of our 2 values here, 5 and 6, which is 5.5, and that is our value for Q3. 5.5. So we found our 5-figure summary. Our 5-figure summary is our minimum is 1, our Q1 is 2, Q2 is 4, Q3 is 5.5, and our maximum value is 18. We're asked for the interquartile range as well, so that was us answering A. If we answer B here, our interquartile range, IQR, is equal to Q3 minus Q1, so the difference between those, which is 5.5 minus 2, so our interquartile range is 3.5 there, 3.5. Now we can use the interquartile range to determine just when an outlier is occurring. We can look at setting some limits on where outliers actually occur to see whether any of the data that we are looking at actually has any outliers in it. So outliers are determined by finding what's that upper bound and what's that lower bound that kind of box in. This is where most of the data sits, and anything outside of those bounds, that boundary, is an outlier. So if we have a look at how we can determine the upper bound on an outlier, so that's the absolute maximum value that could be considered a value that's part of the main set of data, is Q3 here plus 1.5 times the interquartile range. If a value is greater than that, then it is an outlier. So if we were to determine that upper bound, so our upper bound here, upper bound is going to be equal to the Q3 plus 1.5 times the interquartile range. If we found a value that's larger than that, then it is going to be an outlier. The lower bound on outliers is if we take Q1 and then take away 1.5 times the interquartile range, then that's the lower bound. Anything lower than that value is considered an outlier as well. Now it's important to realise that either of these two equations might be different to what you see in the future, and it depends on what statistician is writing a textbook, or what statistician is considered the lead statistician in the world. You might see it relating to the bounds for an outlier relating to the median rather than Q1 and Q3. But the textbook that we're using uses these definitions for the upper and lower boundary. So these are the ones that we are going to use. Let's look at an example on how to do this. So we're going to use exactly the same data as we used for the first example. So we're being asked that we find any outliers, ensuring that we explain why they are outliers. So for our first example, our 5-point summary, the most important pieces of information we need to determine these boundaries on where the outliers lie is that Q1 is equal to 2, Q3 is equal to 5.5, and our interquartile range is 3.5. So in order to work out the lower bound, if I want to look at the lower bound, that's going to be Q1 minus 1.5 times our interquartile range. So our value for Q1 in this case was 2, and we subtract away 1.5 times our interquartile range 3.5, and if we put that into our calculator, we get that our lower bound is negative 3.25. So that means if we had a value lower than negative 3.25, it would be considered an outlier. We don't have any values that are lower than that, so it means that we don't have any lower end outliers, values that are much smaller than our main part of our data set. If we look at our upper bound is Q3 plus 1.5 times the interquartile range. So our value for Q3 was 5.5 plus 1.5 times 3.5, our interquartile range. And if we plug that into our calculator, we get that our upper bound is 10.75. So, because we've seen that 10.75 is our upper bound, if we have any values larger than 10.75, they're considered outliers. Lo and behold, we have a value that's larger than 10.75, 18. So we can then say, therefore, as the upper bound on outliers is 10.75, 18 can be considered an outlier. Okay, so we've determined that 18 is an outlier. It's the only outlier that we have, and it's because it's above that upper bound that we've set from those definitions of where the lower and upper bound on outliers should be. So if we recall, we think back over our learning goals for this lesson. We determined the 5-point summary of or the 5-figure summary of a set of data. We've also had a look at how to determine the interquartile range, and we've also looked at how we can use the interquartile range to determine whether any outliers exist in a set of data.